or earlier I was building AI. I started as a freelancer for building AI for some of the US clients back in 2014 and 15. This is how my AI and everything started. And then I started building for Aptus, or that is known as Conga. Some of people from Conga has joined here. I was the very initial members who developed the AI for Conga, that is CLM AI for Conga. Then I happened to do some adventure in my life, and I became a founding member in one of the startups called as Avenir. However, we raised till Series A, and yeah, but then after 6 years, I mean, everything is good. Everything was good. Then I thought I wanted to build something more. I wanted to. I mean, I felt that my potential. I'm not using my potential to the maximum extent. So hence, I thought that I want to do even more. I mean, it was becoming hard for me to convince everyone that what else we can achieve in AI. So then I thought I will take a solo journey, and first I would like, I thought that I will start with, interacting with students. Even as of now, I have again, like, I am again a AI consultant for, especially for like legal use cases, and I am consulting on a project for Cognizant. So this is, yeah, but yeah, I mean, I keep on researching on AI, and I have future plans on AI in terms of education and this thing. So this is how I started, and I had really some weird ideas regarding education, which I can discuss with you. I will be discussing with you also, obviously, right? And we'll see that how it goes. You may agree or disagree with a lot of things, but that is okay. That's the whole point of coming together, right? So welcome to AI. What is the today's agenda for AI? That how AI came into existence. AI is wild. AI has really gone wild. You see all of those like posts and everywhere, fear mongering posts. AI is going to take this. AI is going to take that. AI will come after your jobs and everything. I was able to create a startup from AI. I am able to create $1 billion from AI. Yeah, but I mean, many a times I see a lot of people that they cannot comment on that, and they might even get feared up. But yeah, I mean, this is the whole point. We will break down every single bit of AI, what AI is, in what state of AI is today, and you will be able to see that what is the future of AI. Now, all of this boom, is it the first time in AI that has happened, or it has happened even before? I mean, a golden phrase that everything that is happening now has been repeated in history. So same goes for this also. So we'll see that what are the shortcomings of AI, right? And all of these things. Yeah, I mean, this is a long course. We'll talk about, but this is today's agenda, just that uh, what AI does. And in the end, we will be writing a small model. I mean, this is going to be a small model. Obviously, I will have to work hard with you guys to make you AI programmer. Now, the agenda I had sent to you, all of you, that right here we have the agenda here. I hope, yeah, it's visible on my screen. So here, like I said, whatever here is written is 100% true. Nothing is, I don't wish to have any deception or something. Like module 1 is completely free. I mean, no questions asked. If you do not feel that I'm not getting comfortable with the course, that is okay. Because the whole point being that you all should get some value out of it. The point is not that I should force you into paying fees or something. The whole point being you should get some value, and then you should deliver some value around. I mean, after that. Now, some of the students, I used to teach 15 years ago. Some of the students have rejoined in this lecture after 14, 15 years, and there are 4 to 5 of them. Obviously they found some value earlier, and hence they also see that, okay, this guy might provide some value again. So yeah, I mean, this is the whole point, that yeah, one project is completely free, and what we'll be building is we'll be building our own mini LLM. Now this is not a couch potato course. What is couch potato course? That you sit and you just watch videos on the couch and that's it, it's over. It doesn't work that way. You will have to pull up, hence I said you'll have to bring your laptops and you'll have to do it yourself in the sessions, and thus you will learn. There are certain assignments also I'll be giving you, which you will solve, and I will solve your doubts. In the end, basically the whole point being, we should be able to complete at least 3 projects, and you should have completed all of those 3 projects. Right. Now, the obligation here for you is that if you complete it, obviously it's your success, right? Now, module 1 is PyTorch. We'll be discussing the PyTorch and everything, fundamentals. Module 2 is basically whatever you see nowadays, if you want to fine tune your own LLM, what this LLM can do, what this LLM cannot do. Yes, we can only make it do what it can do, right? There are a lot of posts just circulating around. There's a lot of misinformation around it. So we'll see that what it can do, right? Then the most important points, once we have learned that what it can do, the point being we have to inject it into application, right? Agents, multi-agents, LangChain, that is a framework for using LLMs, basically building application on top of that, and RAG, retrieval augmented generation. These are the top 3 applications of AI. Now this is module 4 to 7 is application based, but these 2 are the fundamentals, and especially, and hence I came to this first part. If you learn this first part, you will be never outdated from AI, because everything is made from this only. It may be LLM, it may be like any application, stable diffusion, image generation, video generation, anything you talk, it is made from this basic one. So if you just learn this basic, you'll never be out of date. Second point, like, do I aim that you should become a coder or something? No, I mean, in this time when AI is coding, that is not the point. But obviously, if you want to become AI engineer, then yes, you will have to get proficient. But if you want to be an entrepreneur, right, you want to build something, right, like even I am dreaming, then obviously you will have to understand the business perspectives. You will have to understand how this AI is working, right? Obviously, if you complete this assignments, it will be an add-on, and you're never gonna regret in life that, okay, you will always understand that, okay, what anyone is doing, no one is able to fool you out, and all of those things. And apart from that, we can also have one session around like how, if you want to launch your own startup, what are the steps. I have those experiences on hand, so we can go ahead, and in future, in or 7-8 months, I'll be again beginning with this journey. Right now, some of the points that, how many of you have these questions in mind? And these questions are, do we require mathematics? Do we require a lot of coding? I mean, am I even fit to learn AI? There are so many concepts to cover before starting AI. We need to learn all of that. I mean, every one of you might have gone through LinkedIn posts saying that, uh, like, you need to learn X, A, B, C, X, Y, Z, and even the Z characters will fall short of the number of courses that say about learning. Now, are they lying? They're not, right? Then what is it that we are going to do? Now, basically, what I always think is that right now, what I have always thought is that how we have been learning till date. Let's say you wanted to from first to 10th standard, what all we have been doing is that you have been learning a lot of course, lot of theory, and then we see the memes around that, oh, where are you going to use this cos theta and sin theta, right? Where are we going to use this? I mean, so boring concepts. Yes, if this is how we teach, they are going to be boring, right? So basically, how we are going to crack this whole thing. And I have always been learning this way because I have been a big no for this whole thing. That is what it says is, first you learn all of the theory, first you learn all the theory, and then you get information overloaded, uh, and then you sometimes even go on learning irrelevant things. You do not know what you want to build with this theory, right? And all of those things. Instead, what I always feel, what I have always done since past 18 years is that I always captured a problem. Let's say there's a problem I need to solve, right? And I need to solve a problem, and then I started doing all the research on it. Now, let's say in past 7 years, I have been researching on quant finance. This is something I have been researching on. And then around 2 years back, I had no idea of this field. Then I researched on this quant finance and I applied it to AI. And then I learned a lot of things in the journey. I do not need to get all of the fancy MBA degrees now. I'm not saying that they're useless, but yes, the whole point being I'm trying to make here is that the way of learning. So we capture a problem, we see what is the problem, and then we start doing research on it. We'll do the research on it, all the required research on it. Sometimes you will go with the right research, and sometimes you might fall off, but that's okay. You will learn something, you'll come back to research, and you'll start doing. And then you will finally make a blueprint around that. What is the blueprint? Where do I need to do? And then you need learning and development and testing, and finally you have a solution. And when you have the solution at the end, this whole journey will have taught you so many things, so many things you might have learned in this whole journey, that you'll have learned a lot of things. And what you will realize that I did learn all of that, moreover, with higher motivation, with higher application. uh, so the theory is very simple, that this is what we are going to follow here this time, right? There is no point I pull up all of the theory of the word, saying you that, this is what it is doing, this is what it has done, and then all of those things. First, we'll see what are the problems, because, the whole point being all of these problems are real life problems, right? At the end, they connect to normal person. They may be solved anyhow, right? They may be solved via mathematics, they may be solved via advanced AI or anything. At the end, it is about content generation, or it is about image generation for media, for marketing, etc., video generation, for all of your marketing campaigns, sales campaigns, and everything. Now, the other point that I very strongly feel, creation is fundamental nature of humans. Now, what we have always seen is, we have seen this course, that is how many marks and grades we have, right? Now, all of these scores and grades are good, but again, the point being, they don't give you the real motivation, right? The real motivation only comes when we talk about what are we creating, right? The art of creation, this, and when you create something, it may be very, very small thing. Now just relate it to anything. You might be creating certain box, or anything, any small thing or any big thing. Programmers can relate to it when they create something and it runs from end to end. The amount of satisfaction that it gives, it is because, it is psychological, that it gives you a dopamine rush of the highest quality, right? So creation is the fundamental nature of humans, and this is how we are going to learn. This also cracks with one more problem, that anyone can learn anything, right? You're not bound. Yes, but you will have to, if you want to learn how to create rockets, you'll have to dedicate that much amount of dedication, right? That commitment should be there, right? So anyone can learn anything, and this is the methodology that we are going to follow here. Any questions, guys? Anything, any suggestion anyone would like to add? Is it good? Is it bad? Anything? Okay. Vikram has given a thumbs up. Anyone else, team? All right. Cool. Thank you. Thank you so much. Right. Right. And this is what we said, that creation is fundamental nature of humans. Right. The other point also that I feel is that the way all of these concepts have been presented to us, you know, all of these concepts till date, whatever we have been learning, uh, these all concepts, let's say, if even if I want to teach anything, geometry to anyone, right, it has to be so simple that even a normal person can grasp it. If a normal person is at least not able to get the basics of the geometry, then like I'm not really doing my job in conveying the right thing. And since geometry is dealing with really normal day-to-day observations, obviously there are more advanced formulas. But yes, I mean the basics I should be able to convey. And this is what I come up with this course also, right? Everything is from zero, grounds up. This course, who, I mean, what do you expect out of at the end of this course? Obviously, one of the aim is that software engineers to AI engineers, that if you're a software engineer and you want to convert to AI engineer, this is for you. Entrepreneurs, I mean, if you feel that, you know, you want to have that this AI edge in your organization or in your any future entrepreneurs, you want to launch anything, right? Students aspiring for career in AI, obviously, you might have somewhat less uh, pressure as of now, but yes, as compared to all of these three categories, but definitely who want to have their career in AI, who want to create new models and crack new ideas and everything. You know why I said about all of these things? Because the first thing that we solve is a problem. So even problem hunting is first the big problem. I see a lot of people struggling with just this part, problem hunting. You know, they come up with anything, they can come up with any thing, and they just say, okay, we'll just attach ChatGPT into it, and that's it. This is AI enabled and done. No, this is not. Right? You'll have to come up with the proper business solution. First, you need to identify the problem where it fits properly, right? And what all it does. So, and then you can actually go ahead and see that how this problem is getting solved. I mean, this is very simple, and yes, it can work for some time, but yes, I mean, we cannot just move too high just with integrating chat gpt in anything, right? And then obviously the problem solvers using AI, the problem solvers who want to solve new problems, again, we can see that they again fall into the category of future entrepreneurs. Definitely. Now the point being, what I like I said, we are going from problem to solution, right? So what I want is bring your own problem. Obviously, I will be giving you all of these projects and everything. We'll be doing all of this thing. But the point number one being, start thinking. You need to start thinking. Now, this is something I can tell you, but you have to do it, right? You have to just sit somewhere and you have to just start visualizing that what all I can build, what all I can see, you know, uh, like uh, one of my colleagues have joined here, and how we used to call that we have eyes with AI lens. That is, we always see that whatever the problems are there and that have not been solved with yet not with AI, how we can actually use AI. I mean, not just using Chat GPT. Like there are various ways we can solve it, right? So you need to get that AI lens here, right? Not just, I mean, and Chat GPT is not just AI, right? We'll talk about it. It is not AI. I mean, it is AI, but it doesn't mean that only AI that exists in this world is Chat GPT. There are so many different versions of AI, right? that we'll see to learn and what it can do and everything, right? So the whole point being that bring your own idea, right? Chase your idea, right? And I what I can do is I can help you in implementing. Now don't come and say that implement this idea, right? Because it takes a lot of hard work in doing that. But yes, I can help you, and whatever the stage, and if at all, whatever the stage your idea is, we can go ahead, and at least I understand the uh, all of the VC map here in India and even abroad. But yes, I mean, that's a separate problem. Not every startup needs a VC, right? There are startups that can start without a VC also, right? That is investment. When I got that is the investment. Not every startup needs an investment. You can actually go ahead and start your startup without investment also, and not just in startup. I mean, definitely, if you really find a lot of joy in building solutions for others, I mean, absolutely, do not fall for this mentality that, oh, I am not building something, someone else is building and startup, so I'm falling behind. There is no rat race. Do not be involved in any rat race, right? Just uh, look on to increase your knowledge, right? That is the whole point. So you can build your solutions for yourself. It is equivalent. You may be building solutions for some organization. That is again equivalent. And you may be building some solution for the society or something, right? Again, that again comes. Right, how AI came into existence. But before going to this slide, actually, what I want is, I wanted to discuss one more slide here. Basically, uh, I wanted to talk about the current state of AI, what it is, and like a very common thing is that everything, you know, uh, ChatGPT is the only AI that we have, right? No, that is not the case. Right? Okay, so basically, AI is a very broad term. AI is a very broad term. I will just cover one use case from 1940 recently. Now, not purely AI, but yes, something that inspired AI, right? So AI is of various kinds. Now, AI is problem solving. It is problem solving, right? Just what you have been, I mean, if you're a software engineer, what you have been doing, if you have been consulting clients, you have been doing that also again. But problem solving using a different tool, right? Now, what is that tool? I'll just briefly describe what is that tool. Now, let's say till now, what you have been doing is, right, uh, that let's say there is any problem around reviewing of a document. Now, this is something I have been doing a lot, reviewing of a legal contract. That's a small problem. Now, till now, what we have done is we made various software tools around it, right? We made a software tool. This is a contract. This will go to customer, and then customer will mark here. He can comment here. All of the word features also everyone has seen. They can that they will comment here and do all sort of things. Right. This is one way of achieving solving the problem. This is basically we are assisting in solving the problem. Right. Now with AI, we have different set of tools. First is obviously what we can do is that is all the AI is around pattern recognition. This is the core area where AI works. And I'll show you even the basic thing, the pattern recognition. Now this pattern recognition works in such way that it gives us an impression that AI is thinking. Yes, this is true. I'm telling you that AI is really not thinking. No, AI is really not thinking. It is giving you an illusion that AI is thinking, right? Because it has pattern recognition skills. Now, this pattern recognition can be anything, right? This pattern recognition, now, if we just go, now, what I very strongly feel, that pattern recognition is, oops, This pattern recognition is actually the core of this word. You know, you can solve any problem using pattern recognition. Now you see, pattern recognition can be seen in which all areas. Pattern recognition can be seen, it can be seen in, you can see pattern recognition first starting around us in weather. There is a pattern around it, right? Our forefathers knew it, and this is how they have been seeing, right? There is a pattern around all of the planets, and this is how various sciences around astrology and everything was formed, right? There is a pattern around behavior of people, right? So since if we are able to capture it, we can predict it, right? And hence we can predict this. Similarly, we can predict this up to a certain extent. Similarly, we can predict this also, right? Behavior and anything. Basically, there is a golden rule that anything in this world is measurable. When I say that I am covering a different slide also on this. Anything in this world is measurable. That is, you come up with any problem, it can be converted into numbers. It can be converted into numbers. And this is what ChatGPT has done. That is one of the dimension, or one of the part is that ChatGPT has been able to convert text and everything and solutions into numbers, and it gets trained, and then it basically outputs you that. Now, a recent application being in, I do not know if you have noticed or not, in IPL, right? Basically, in 2023, I guess, I went to one of the AI conferences, and in that AI conferences, the discussion was, then someone came up with, how can a cricketer is playing and he hits a shot, how do you measure that? And hits a shot, how do you measure that? And I came up with an argument that yes, it can be measured using angles, using force and everything. So these numbers, we just need right parameters. We do not have right tools as of now, right? However, 2 years down the line, and what has happened is, after two, in IPL, if you even, I do not know, I saw this in IPL, that there is a cricket bat and it has various sensors available to it, and it is connected to your system, and basically as you play, and it detects your pattern, your force, with how many accuracy, how much accuracy have you hit the ball, how many times you have hit the ball, and are you improving or not? Are you improving or not? That is, if the accuracy have increased for hitting the ball, has it improved or not? How much this ball has traveled, right? So it keeps on measuring all of those things. So here I come to the same problem, that in future, now this might give some more wings to your brain, that you can actually convert any problem into numbers, and then you convert those numbers and you send it to, or you like create a small AI around it, and then you can do the predictions. Like you can do all sort of things. So yes, I mean, AI is just another algorithm around us, right? Just how does it make look so complex? We'll just have a look around it. Right? Now, how does AI came into existence? How many people have seen this movie, The Imitation Game? How many people have seen this? No one has seen. How is it? Okay, a wonderful movie. Now, this is about a person called Alan Turing. Around whom we have the Turing test. We have Turing tests, right? This is for AI. If you search Turing test, and he created back in 1944 around something, right? A brilliant, bring the real photo of Alan Turing. This was from the movie, basically the real photo of Alan Turing. Now, I just want to cover one more such example, that how does AI came into existence, so that we have that idea that, oh, this is how it was formed, this is what AI is. We do not say that, okay, this AI is a black box, and we do not understand what is going inside it. Up to an extent, you cannot understand, because, I mean, the same thing, if you have lakhs of switches, I mean, I just say, if you have lakhs of LED bulbs inside your like lightning system, and some of them fail, then it becomes very hard to debug it. The same is the problem here. The simplest unit we understand, but when all of these units they come into huge amount, it becomes hard to understand, right? So the time was 1944, right? World War II was high, and the German ships were actually killing Britishers. You know, a lot of ships have been shot down, and Britishers, they came up with the plan that, okay, let's intercept the signals of German, whatever the signals they send to their ships, and let's intercept that, and then what we can do is we can know that what they are trying to do. But Germans were one step ahead. What they did is they invented a machine called Enigma, right? Now, this machine, what it does is, this machine can, no, now in 1944, there were no computers, right? Nobody knew any algorithms. All of the calculations were done by hand. So basically, they came up, this was a cryptography machine kind of. So that is, every day it generates a new pattern. Every day we reset the machine and it generates a unique pattern that is not used in the past. That is, let's say, if you have to send a signal that approach U-boat XYZ, right? Then basically what it is going to do, every day the same message will be sent with different set of characters and numbers. And cracking this was just impossible. And as a result, Germans started gaining an advantage because of this communication method, because now they could not be intercepted anymore. However, what happened was, then basically Britishers, they approached Alan Turing and his team, and he was a professor of computation at that time, and he was writing research papers. He had his own ideas that this is how computers could be created. I mean, he used to call them different machine all that time. So basically, what was happening, that you choose any, let's say on this day, this is the message being sent, and this is the message that will be sent, right? And it will be converted into this, and same message converted into something else, same message converted. So I mean, it was uh, baffling for British and US, that what the hell is happening. I mean, how are we going to defeat them? And then came in, I mean, so the German U-boats sank approximately 2,800 to 3,000 aligned merchant ships. I mean, a lot of, I mean, in those days, 14.5 to 14.9 million gross tons of shipping. I mean, they destroyed the business and everything, and especially they were targeting the food ships and everything. You should watch this movie. It's a wonderful movie. And then what happened? So Alan Turing came up with an idea. He said, I mean, this cannot be cracked with hand. So let me create another electronic machine to encounter this. He called this a bomb machine. Now, basically, this was the first like blueprint of what computers will be in future. Now, basically, what he used to do, now this was not exactly AI, but this is how, I mean, the things people started thinking in that direction. Now, basically, what he used to do is, let's say he used to capture a message called, let's say, good morning or something like Hail Hitler, right? So he used to capture this kind of message that, okay, these two words can be in morning, it can be good morning, in evening, it can be good evening, or something like that. And then he used to send these two inputs to his machine. Now, his machine was basically, what it used to do, it used to automatically detect all of the combinations and then come up with the key that, okay, this is what is mapping whatever they have entered. This pattern is mapping this word or this pattern. So this is how they started decoding uh, basically their messages. And if you just go and check, uh, due to Alan Turing and his machine, World War II was wrapped up in much smaller time, and this was one of the very huge point wherein due to which they could win the war. Right now, basically, he came up with this machine. Uh, right, he came up with this machine. The whole idea was this. Now, at that time, just imagine he built all of those things with just electronics. All electronics and everything. And when he built this machine, obviously there was a certain boom that started, that okay, now machines can think and everything, right? Just like how we are discussing that machines, AI is the next AGI and everything. So humans have this bad habit of doing that every time we see something new, right? Now again, coming to the same idea, that this whole thing is actually working, that fuel for intelligence is that everything in this world can be converted into numbers. Anything. It is just the matter of time. Sometimes we have tools to measure something, and sometimes we do not have tools to measure something. Now, if this is one area that you are able to conquer, now this is not something that some books are going to teach you. This comes out of creativity, sheer creativity, right? Now, anything that you are able to measure it, and once you are able to measure, after measuring this, then basically we can do all sort of things. We can automatically detect that what this is doing. We can detect, we can predict, right? Analytics, we call it like analysis, right? We are trying to find the hidden information in this analysis. We can predict, we can forecast that what it can do, right? We can forecast, or we can transform it into another format. We can transform into another format, like you wanted to convert it into dashboards, or you want to convert into any other format that any device should consume, or something like that. So this is the basic of AI, right? What it does is that the kind of common applications it has is, first is it will classification. That is what this data is, classify this data. Then after classifying, transform the data. That is transform the data into some other format. Then we can do is forecast the data, forecast the data into some other format, right? And then what we can do is we can even now, this new chatbot and everything has, you can even chat with your data. But yeah, I mean, that is something different. So this is how various kind of AI come into existence. All of the different things that we can do with AI. So we can forecast, we can, and these are just some limited examples. Sky is the limit. You can think. So here the core idea is thinking and thinking and thinking. This is the core idea. Hence I said in the beginning of this whole session that you need to think, and everything else will just start falling into the place. You need to come up with the right problem. How do you need to solve it, right? And the vision, right? And then automatically it starts falling in. I mean, you start working towards it. I mean, if you go and read about Steve Jobs, I mean, Steve Jobs did not knew to create an iPhone from the first day he started, right? It was not the case. It was the vision. And with the vision, how strong your vision is, then you come up with the solution, you come up with the research, you come up with everything. You will face hurdles, but yes, ultimately you keep on solving it. And the same analogy goes for learning also. You pick up a problem, you collect the data for it, you have the right tools to analyze it, forecast it, and you have a solution, right? Correct. And next is basically, so all of this thing, whatever we have, you know, this whole story, after that, the Alan Turing created everything. I'll have one more slide here. After that, Alan Turing, he created everything. And then what happened? Basically, Alan Turing went on to create one more machine for himself. And he went on to create a machine for himself. And again, with the same thing that, okay, this machine can automatically do everything, the same kind of pursuit that we are trying to follow now. Now, in 1957, the year was 1957, and in the year 1957, around, a new term was coined that was called as perceptron. Perceptron. Now, why this perceptron is important, you need to understand this, because till date, all of the AI is working on this perceptron. Every AI that you see, image generation to whatnot, to everything, is working on this. Now, let's try to first understand what he gave, and we'll also have a look at the funny story that they created, when this perceptron was created. So basically, he came up with this idea. Frank came up with this idea in around 1957, right? And this perceptron was an electronic algo kind of electronic machine. So first he created on paper, then he created electronic machine for it. Now, perceptron on core, what is a perceptron? So this is a single cell on which everything is operating. And if you see that, it is so simple, right? Now, we are entering towards, till now, whatever the problems you have created, right? Or whatever the problems you have seen, I'm sorry, created, whatever the problems you have seen, they might have been solved, let's say you need to fill in the Excel sheet, you'll pick up Excel sheet, you fill in the data, and done. Right? You'll say that, okay, 100% completed, right? Now you need to fill up a form, you'll again go to one by one and you fill up a form and you're done, right? Now again, maybe if you are building a software, let's say there's a website, you'll say that, okay, client said 3 buttons to be attached, there is something like to be displayed here, and when button is clicked, it should do something, and done. The 100% achieved, right? Okay. So basically, till now, whatever we have been doing, they have a kind of quantifiable output that is either done, not done, or partially done. How much? Like 97% done, and 3% is remaining because one task is remaining, right? These kind of things. This is how we measure. And then let's say someone comes up and he says that, what I want to do is, this is my image. This back in 2010, this is how even I worked with image processing. So in image processing projects, basically, this is an image, and these are the pixels available for, these are the individual pixels available for image. Now, what we want to do is, these individual pixels, right? We will go and read that what RGB is there, or what channel is there, red, green, and blue, right? Because I mean, at the end, everything is basically pixel here in system, and every pixel is again a number. It is again a number, right? So then we'll read that, and then we'll use various kinds of like mathematical regression and for advanced algorithms to build, okay, this seems like this is how it is, it seems like this is making a pattern, okay, this is a pattern. Or if you want to convert it into black and white, I'll basically convert these RGB into, I'll change the channel of the colors, right? and hence it gets converted into something else. But however, now this here, what we see is a new kind of problem solving. What is this new kind of problem solving here that we see? Now, let's start with some example here. So anyone has any doubts as of now? Everyone, no one is having any doubts? Okay, cool. All right, right. What what it came up with the every now it also said that almost every problem can be solved with this new ideology, and this ideology is that, let's say, now there is a farmer, right? And the farmer here says that, you know what, I do not have any idea. I'm not able to get that if my plant, there is a plant and it has some leaves, and it says that I do not get any idea that what kind of disease it gets. I mean, I just get to know that it has some disease. I don't get to know that what kind of diseases it has. I mean, I'm not that educated. Even if someone is educated, it is very hard to find out this thing sometimes, you know. So it says that, you know, it's so hard to do that. So what do I do? So earlier, I mean, one solution is that we say that, you know what you can do is you bring that leave to us, and either we'll test it in the lab or something like that, or you call an expert, or you send the photograph or something like that. Right. Okay. All right. Anyways. Right. We're here. So it says that either you call to an expert or something like that, and if we have to solve this problem using computers, then what we can do is, I mean, automated way. I mean, it was dead hard, you know, a hell lot of image processing and everything needs to be done. And actually, this was so complex that this problem was never addressed itself. I mean, the problem was there, it was never solved. The disease detection in plants and flowers and trees, right? It was never seen. Now, then the new way of solving is that what we say that, okay, what we can do is we can train a machine. How do we train it? This is the whole problem, right? So now just see that we have, what I did is I collected samples of this plant photograph, right? I collect the samples of plant photograph. I say to farmer, you do one thing, not just you, but your complete village, tell them to at least come up with the photographs. Then I collect these photographs, right? Okay, this is sample S1, sample S2, sample S3, S4, and S5. I tell them, okay, you bring all of these samples, and this sample can go on till sample like 1000 or anything depending on the model, right? Now I say that, okay, bring all of these samples to me. Then what I will do is, this is my uh, input, right? My input is what? Input is sample of the photographs of the leaves. And then I say that, okay, I catch up an expert. I say that, okay, hey, expert, come here. Now, since you already know that what this disease is, let's say we have diseases of two kinds, four kinds, or D1, D2, D3, and D4. So next, what we are doing is we are mapping them. Just so there is nothing complex in all of these things. Just vocabulary has changed, right? This whole mapping thing, we call it data labeling. We came up with a different terminology for this. We came up with data labeling, right? You see, one thing you need to understand that everything is just with a different vocabulary. And first, you need to develop this thing that, okay, there is nothing that I do not understand. And second, if there is anything, it is just via different means, different vocabulary, and all of the different, I mean, sometimes obviously there is very rare information that is just too complex to understand. Most of the times the arrangement of the information is so complex that it becomes for human to confuse. So most of the times it is that. Now here we come about mapping, right? So what I do is this, okay, this is my output, right? This is my output thing. I do is D1, and then I go for D2. I go for like this is D3, and this is again like something as D1 again, and this is something again like D2 again and D4. So I've done the mapping, right? And now I have the big, huge, let's say, CSV or something like that. I mean, CSV will not contain images, but it can contain the link to those images, right? So I have like I1 is mapped to D1, and I2 is there with D3, and so on, so on, so on, right? Next, I will feed it into my model. Now, what model to choose and what not to choose, we'll have a look at it later. I mean, we this is what we are going to discuss 3 months, right? And by end of this, you will be easily able to identify how to do that. Basically, models are, now pay very attention to this line. Models are mammoth size mapping engines, right? They're mapping engines. This is our progress till date. Now, will it be the same in future? No. Why? Where it can change, I'll tell you the places also where it is going, it might change. And there are a lot of places, but yeah, I mean, some of the places where this can change. It's a big mapping engine. Now, what you do, it is going to remember all of that. Whatever you do. Now, this can be 1,000, it can be 10,000 also. So one more cool way of saying is model are huge size statistical calculator, right? One more cool way of saying is models are huge size statistical calculator. Or first form of understanding is that they are huge size mapping engines, right? They're huge size mapping engines. Now, I'll just clear it a bit. Okay, this is more easier. We'll go to it. Anyways, they're huge size mapping engines. Now, you see what happens in, you have this complete mapping of image I1 to D1, image I2 to D2, I3 to D3, and all of this you have. Right? And this mapping, it goes, and then it remembers all of it. It remembers all of it, right? And this remember huge mathematical complex matrix, right? Set of matrices is there, right? This matrix is there, and huge matrix in the same matrix that you might have studied in your 10th standard. This huge matrix. Now there are some other formats also. Now basically the whole point being, it is storing numbers. And what numbers? The mapping numbers. So this AI, as of now, most of the game is about mapping, right? Now we have mapped it and it gets stored here, done. Now the point being, this was our trained data. This was my trained data, right? Now what I need to do is, I have my model. Okay, this is what we call as a model, right? Model will have all of my learning here, learning, that is the mapping here, right? Now obviously when you sit, if you go for an AI interview or something, these are very simple vocabularies. I mean, you cannot say in a very simple term that this is a mapping data, right? You'll have to use that sophisticated vocabulary, right? That all of every other people or on LinkedIn everyone uses, right? So now what happens? Okay, I got this model and I install it, let's say, on a cell phone, right? I install it on a cell phone. Okay. Now what happens? I give this cell phone, okay, to the farmer that, hey, farmer, you know what? Take this, and this is automated AI advanced satellite detector, right, for your plants, right? You give some advanced quantum name to your application, right, and you give it to that farmer, and farmer will feel, oh my god, what is this? This is like a living being. What have you created? You are a master here, right? Okay. And then what he's going to do is he'll click photo and it will classify, because it already has something. Then if the image is now not present in your it was not present in your training data, it might send wrong also. It might wrongly classify, or if you have very clearly done the mapping, it might say that, sorry, I could not detect it. Then you can wrap it up in a message saying that, yeah, it is still learning, right? This is how it happens. Yeah, it is still learning, right? And if it is wrong, then you say that, I mean, you can say that same message that, yeah, it will come up with the time, it will advance with the time, so that, you know, the whole thing, that it should feel that, yeah, it is live thing. So this is what most of the AI is all around. And now, if you feel that, you just start recalling the scenarios when ChatGPT was released. When ChatGPT was released, basically what used to happen, it could not answer simple thing, how many R's in strawberry, because it was not trained to think that way, as simple as that, right? So what they're trying to do with ChatGPT is they're trying to teach it as many as solutions possible in the world. So whatever the things it gets, whatever the interactions you have, they take it in the data, right? This is what they convert into training data, all of the internet data, and all of from the books and everything, you know, they do all of that, and then they dump it inside this machine. Yeah. They have been trying very hard to change this nature of the model, but it is not changing, right? Now, is it going to be this way forever, or what? See, basically, what you need to understand, till the time we'll discuss about, I mean, we'll discuss about more in transformers. Again, transformer is again one more architecture, right? And I'll just break it down what all of these architectures means. We'll just understand it very clearly, that what all of these architectures mean. Now this transformer thing, what is there, that all of this transformers and everything, right? So we are still at the same stage, that it is still learning patterns only. It is still learning patterns. What will be real AI, or AGI that they call, general intelligence, artificial general intelligence, is basically a scenario wherein you have a problem, right? And there is an AI here. It comes, this AI, and it automatically it comes up with all of the solutions, S1, S2, S3, S4. It comes up with all of these solutions. It think all of these solutions, and then it evaluates all of these solutions, right? It evaluates, and then it gives you an answer that never existed. Basically, let's say I say that, okay, this is my theorem and you need to solve it. Now I give it to AI, let's say someday AGI, and it automatically does 2 days, 3 days, or a month of calculation, depending on the complexity of equation. And then it comes up with some solution saying that, you know what, I have found the solution, and this is your solution, right? Now basically, why do we need even agents? This is the same reason as of now, right? This was something that AGI might have, and there are other ways also, but this is one of the common way, right? AI might evolve into AGI, right? Now going forward, right? Now first we need to understand that what this AI, and you know, how I already gave you an example of the mapping tool, right? How does this mapping actually happens, and how does it automatically does it? Now I give you a very simplified example. There are very complex ways of just achieving it. And what I was coming to the point, why do we have AI agents as of now? Now let's say if we really had so smart AI, so I could have just said that, you know what, go to this website, go to website, search for cheapest prices of hotels or flights, and book whenever available, right? I would have just said and done that. But no, what AI agents are now, so basically these are small like AI tools, right? One tool goes and it interacts with your website, it is specialized in that. And there is one more tool, it goes and search for the hotels, and there is one more, it does the booking, and they interact with each other. And thus we need now, since we had realized that okay, this AI as of now, at least for some years, is not going to get utmost intelligent. I mean, we are not going to make it very intelligent. So let's create more framework around it so that its intelligence increases, its automation increases. So hence we have all of these AGI agents and everything. We'll talk on that. It is very important to choose when you should use these AI agents and when you should basically even add more data to your model, because if you add more data to your model, you will need less of these things, right? Right. Perceptron was the basic thing, you know. So now I'll tell you a wonder that everything, Perceptron is the most simplest. Right. So what Perceptron, we talk about Perceptron, right? I started with Perceptron and then I went to all of other stories. Perceptron is the basic smallest unit, right? Can it think? No, again, as of now, we do have AI, but yes, even this smallest unit, it is not thinking. What it is doing, a new way of solution it is doing is, it has these variables, right? There's the reason I'm calling them W1, W2, W3. Every perceptron will have these specific variables, right? Let's say 3. We can configure them how much we want. And these variables, based on your output, now remember that mapping point. Based on your output means first you will have to tell that, okay, for this input, for this I1 input, O1 is the right output, right? This is labeling, what we call all mapping, right? We call it now labeling, right? This is what is labeling. Now we have this output, right? Now what it is going to do, it will check the smallest one unit. It is go and check that, okay, this I1 and I2, and here it has some variable. Basically what it is doing, it is just trying to adjust these weights, right? So that your mapping happens to the most optimal point. These are called weights actually, but these are variables basically, right? Variables, it will have values like 1.25 or 2.25 or something like that, or right. Now, I mean, you don't need to you don't have to do all of these things. Not everyone will have to do all of these things. In fact, now even nobody is doing all of these things. But again, uh, I'll tell you the advantages that basically sometimes you burn out literally millions of dollars and millions of literally dollars just using these ChatGPT and other tools. But the same problem could have been done in 20,000, 30,000, or even less dollars, because if you do not know the basics, then basically you will not be doing all of these things, right? Or you will not be taking the right decisions. And this happens for real. People do not have the right knowledge. What they do is they say that, let me purchase this also, let me purchase this also on AWS, I'll purchase this also on AWS, and they end up paying millions of dollars for that, right? And this is what actually all of these cloud giants want, that you purchase everything from them and you should not know anything, or you should not do all of these things from scratch. Now, again, this also doesn't mean that you should every time do from scratch. So there is just a proper balance that needs to be maintained based on the problem, right? So all of these weights, right? Now what happens? I have input, I have output, right? And then I have these weights here. Okay, I have output. It says that, okay, your output is still away. Let's say my input is 3 and my output is, let's say, 5, right? Now it says, no, your output is actually away from input, right? Because input and output has to match, right? Your output is away from input. So it will say that, okay, hey, wait, adjust it. Let's say it is getting multiplied by 0.25, right? That, hey, wait, please adjust it so that the output is reduced. That, okay, it will say that, okay, 0.45 is the new value. I'll adjust it based on your output. And now based on, it will keep on adjusting. It will keep on adjusting till, let's say, it says 3 into 1. Let's say it comes up with the 1. 1 is ideal value. I mean, it should be ideal value in this case. 3 into 1 is equal to 3, right? That is, okay, now I have learned with 100% accuracy. This whole process of adjusting the weights is called as learning. Adjusting the weight is called as learning. And basically, once you have learned, then it means that your input is very properly mapped to output. That is the leaves example, that is the leaves. That is, this sample of leaves is very properly mapped to your output. Right? This is the process of learning. Right? So what we are talking was that a new way of problem solving has evolved, and this new way is that instead what you do is, in that big statistical mapper, in this big statistical calculator, you input your data, and then it will remember the output, and based on that it will take decisions. This is decision making, right? Now since you already have the map data, so it will automatically make the decision. So this is decision making. This is what the most smallest unit was called as perceptron. Now this perceptron is nothing. It takes the input. This is I1, and input, like input, there can be one input, there can be two inputs, or so on. But as of now, let's think of one input, right? And one input, it has this weight, let's say, and this input into weight, the same thing, input into weight, right? And there is one more thing. Usually we call one more additional weight. Its name is bias, but it is additional weight, right? So in many of the things, if you'll see additional weight, so this again gets like trained, right? And if you see now, if you go and check weights and biases, there is a very big company also on this name, just weights and biases, right? So weights and biases, basically weights, the whole point being adjusting the weight for optimal output. What is this part? What is here? Summation means this, basically what we are doing, this part, summation, right? I mean, we'll be adding all of them. That is this x1 with w1, x2 with w2, x3 with w3, and so on. So that it goes as x1 into w1 plus x2 into w2 plus x3 into w3 plus this b naught, and hence we get a very fancy equation, even so do not need to be afraid of. I hope now, if anyone did not understand it, please tell me, right? If anyone has not understand any doubts, please ask. It doesn't has to be one-way communication. You can unmute yourself, you can speak out, you can share your views, and please do that. Anyone? Yep. Dhruv, Akash, Karthik, Pankaj, guys. Okay, tell me, is it really this easy? Okay, how is bias obtained? Now, bias and weights are not obtained, right? Bias and weights are not obtained. They will keep on training and evolving. So this is the whole point, the mapping engine. They will keep on training and evolving. They will keep on training and evolving. There are various ways. I mean, we'll discuss some of them in future, right? I mean, you can actually set some random weights, or you can set these weights based on some theory or mathematical calculation, right? But you can start with random weights also. Right? So they keep on learning and these values changes. They keep on learning and these values changes. Now, I would just like to show you, what I developed a small, now these kind of applications you will find online also. But since I was playing around, so this is, I have hosted on my website, that is Invents AI, on the same on which course was there. There's some problem with my SSL as of now. I am trying to solve it. Yeah. So what is the point being here? The same thing. What I'm trying that I want that I should be able to teach that it should be able to differentiate between these blue and red dots, right? I'll go reset. Okay, I'll reset it to a point so that obviously, right? Then I start auto train. That is what I'm doing is there is weight W1, there is weight W2, there is this bias, and you see these are the values, right? These are the values. And misclassified, that is the error. How many were misclassified? As of now, the job of this line is to differentiate between these two, right? These two, right? So its job is to differentiate these two. Now, once I start, you can actually go and play yourself also, right? Now I go and start auto train. Now it says that, okay, it has adjusted to a way that, okay, now I will reset it again. Okay, now this time it has moved away substantially. It will have to move quite inside in order to. Now again it says I will reset all. Oh. Okay, again the line is here, right? And I will start. Okay, this time also it has done it very quickly. I'll reset it again and I'll. Okay, now you see it is visible now, and you see misclassified is changing from 3 to 1, and the moment it goes 0, it will stop. It has achieved the ideal mapping. 0, that's it, done, right? Done. And these are the ideal values. Now if you weight W1, W2 and bias, you reset it. Reset, you see all of these are random values. These are, as of now I have taken random, but you can actually set them to something. I mean, there are some theories that this is how you should set, this is how you should set, that we'll discuss later. But as of now, I'm doing everything very much random. What is this learning rate? Learning rate is multiplicative index. That is learning rate was basically, and I can't write here. Right. I'll just come to this learning rate. That is that into sign that we were taking. The larger the learning rate, the sooner it is going to learn. The smaller the learning rate, sooner, because why I have taken this value. If I take this one, and it will learn. I mean, I will not be able to see that action. So hence, I wanted to learn slowly, right? I'll reset all. Okay, here it is, and I'll now you see these values here. Yeah, misclassified is 5, 4, 3. Okay, 2. It has stuck. It got stuck on 2 this time. I mean, due to some values of random W1, W2, it got stuck this time. I can reset it. reset, and it is somewhere reset. Okay. And again I can try this time. Okay, I guess it has again stuck on 2. So if, okay, no, it is improving this time. And all right, 2. And see, now this one is moving, this is fixed. Okay, I guess it, okay, it is at 0, right? So how is this happening? What I did, this is a dead simple JavaScript code, right? And I have done nothing fancy here. You can go ahead, visit this website. No Python code, nothing has been used. The only formula that I used here is, this is the formula that I used, that I just show you and did show you. What I did was, let's reiterate over the same thing. This is the complete AI. If you understand this, I mean, obviously, there are patterns ahead. Basically, what I did was, right, okay, there is weight W1, there is weight W2, there is this bias, right? Now this input I am taking, right, I1 into W1 plus I2 into W2 plus B, right? Now this is happening. Now I get a value here, V1, and then I take an input that, is there anything misclassified? It says yes. Then I go ahead and again make, should I make incremental changes? Yes, it will say make an incremental changes, because by making incremental changes, it is improving. So this is what I have done. And then I make an incremental changes with something, W1 or W1 delta plus I2 into W2 delta. I keep on repeating this thing till my misclassification is not equal to 0. I keep on doing. Now, don't worry about it. We will be building this tool live, right? Maybe not today, but maybe tomorrow, because we will have to know how to code a basic perceptron. So we will be building this same tool live. This was just for the problem to solution approach, because first I should tell you that what it does. Now, where am I going to use these red and blue dots and everything? Now, basically, this is when I said those petals problem, right? When I was discussing about those petals problem, those petals will be converted into some kind of numbers, right? And those petals will be numbers. And if you visualize those numbers in at least in 2D format, right? If you visualize it in 2D format, it is going to look something like that only. Let's say if you visualize it in this 2D format, then it will have certain, like the width or the height, something, right? Then it will have some will fall here, some will fall here, some are going to fall here, some are, so all of them basically we can visualize in 2D, at least till the data is 2D, we can visualize it. There are more ways to visualize higher amount of data, right? So then it learns basically to draw the line somewhere here, and we say that, okay, sometimes the line is not straight. Sometimes what it does is, okay, it knows that this is how I need to differentiate, right? So it can easily identify these 4 kinds, right? Identifying between these 4 kinds. Now, coming to the same question, that any doubts, please post. Guys, you have any doubts? Okay, anyways, now next, what we'll go towards is Perceptron. But before once more, I have explained you what happens roughly inside a Perceptron. But this simple Perceptron, now what happens roughly, I'll discuss once more, then I'll go into detail. What happens inside a Perceptron exactly, if there is input, right? And there is a weight. Every Perceptron will have its own weight, and it will have its own bias, that is B, or you can take it out, right? W2. receives I1, I2. Inside what it is doing is I1 into W1 plus I2 into W2 plus B. This is the calculation everyone is doing. And then after that, there is small decision maker that says that if this whole value is greater than this threshold, right, then it should be activated, else it should be deactivated. What it means. So basically, guys, why I'm coming back to this perceptron, because this perceptron makes the whole AI world around you that you see. Right. Now this might come as a surprise that is this small equation changing the world? Now it is not this small equation. Now what happens is that a model, what we call is a model, consists of millions to billions to trillions of these neurons, right? They are stacked together like this. This is layer 1. We call it this layer. Inside is a perceptron. This is layer 1, L1. We have another layer stacked together. This is layer L2, right? Let's say it will have 2 or 3. Then it will have L3. This is how it is going to be stacked together. Now, and then all of these will exchange information with each other, right? These will keep on exchanging the information. And once they're exchanging these information, right, this activation function, activate, if this needs to be activated or not, it will decide. Now, some of them will not be activated. Let's say this is not activated, this is not activated, or this one is again not activated, right? This one is not activated. So based on threshold, if the value is too high, it should be activated. If the value is too low, it should be deactivated. This is a general statement. This is the function of activation function. This is what activation function does, right? And if this, there is one more way to address it. We say if this neuron should fire or not, if this neuron should fire or not. That's it, right? And then in the end, all of the AI, the image generation, the video generation, and everything is working on this. It is working on this. Now, basically, what is happening now, if you just pay attention, right, on first time when you understand it, it might be hard to understand. But if you just see that why it has stuck to this problem of only pattern recognition, why it is only stuck to pattern recognition, right? The reason being that, let's say this is one neuron and this is one neuron, this is one neuron, and then we have these neurons, these neurons, these neurons, right? What they're, it might fire or not fire. This one might fire, this one might fire, this one might not fire, this one might fire. So this how. So basically what they will do is they will learn the small digits of data. They will learn small patterns inside the data. This is all this AI can do as of now. Especially these AI that we are seeing. There are other AI also that work beyond these neurons. But most of the fuss that you see around AI is revolving around deep learning. Deep learning is a study of arrangement of these perceptrons in different order. All different kind of AI, CNN, NNN, or RNN, transformer, image generation, video generation is created using billions and trillions of these cells. The most simplest cell. How many of you got amazed with this fact? Yeah, सबको पता था ये. I mean, did everyone knew it? Did everyone knew it, guys? Okay. All right. Make this easier. Yes, yes, yes. We will discuss this once again. Right. Right. So now actually I will give a very simple example, right? And actually what I'll do is I will explain it first. I will reiterate over the same thing, and then there is one small example we will see. Now reiterating over the same example being that point number one, that model, every huge model, deep learning model, right? Deep learning model is made of perceptrons. It is made of perceptrons. Now, second, every single perceptron, as of now, till date, every single perceptron is following this simple formula of I1 into W1. Now, these parameters will vary, right? I2 into W2 plus bias and plus activation. Activation, it will fire or not, right? This is simply deciding it will fire or not fire. So hence, you see the capability, these are 2 points that we noted. Thus, the capability of AI is only pattern recognition of this kind, pattern recognition for deep learning. This is the capability of AI. Now, if you see the AI, if you say that, people talking about all sort of things that, what we can do with AI is we can do this with AI, you can that with AI. Yes, I mean, if you burn billions of dollars and if you just want to replicate small amount of thing that could be done, you can have 10 AI working together to do a simple thing. But at the core, we are not able to break this threshold as of now. This pattern recognition, this AI. The last advancement that we made was in 2017, right? And that 2017, again, it was around perceptron, but just the calculation of the perceptron, we made it more wide. I mean, so that huge amount of perceptrons numbers could be calculated all together. That we'll discuss in module, that is part of module 2, right? That was the major thing that we achieved. But still we are, and hence this kind of AI is more around pattern recognition. There is a very common, some of the very there might be two kind of common opinions that you hear all together, maybe if you're active on LinkedIn with AI and everything, that this AI will never be 100% accurate. Now, if you see that someone saying that, okay, we will make this 100% accurate, this is, no, this state of AI will not be 100% accurate. Either you will have to rewire or re-architecture this whole thing. Then it is going to increase with its accuracy. Or else this kind of AI, it will not be very, because it works on probability. You see, it is working on conditions, it is working on pattern recognition. Or second point being, you train it with all the patterns. But even then, the problem it ends up with, because these are neurons at the end of the day, the problem it ends up, sometimes it learns new things, it forgets some things, right? So as of now, even we do not have that control also, that can we influence these neurons individually? Because I mean, trillions or billions of these neurons coming together, we are not able to influence them, right? This common llama model is that has been released. It is 14 billion model, and that too 14 billion, 8 parallel models. One model is 14 billion. They call it a mixture of models. 8 parallel models will be working together. These are 8 models, each specialized for a specific kind of task. Based on your query, it will reroute to which model should solve this answer, and then that specific model comes in and solves this answer. Right? This is point number one. Now, if we are clear with these points, I will just show a small demonstration that even Google has. One demonstration I did show you, right? Sometimes, when I was also learning in the very beginning, this all, when I understood all of this, that okay, if, how can it be so simple and people be talking about like, even, I mean, this whole AI boom started back in 2016 also. So then people used to call that, okay, this AI would be able to do this, and then I always used to like that. Still, we have a lot to achieve in AI. There is a lot to develop in this AI. Like, just, I have this TensorFlow playground here. Right. Now, basically, what is this? This is again neurons. This is again neurons. Again, what it says, this is from Google, basically. Now, what it is saying, that you take any kind of problem, this is the problem. You teach your AI to differentiate between these patterns, to learn this pattern, right? To learn this pattern, you teach AI to learn this pattern. Now, what I can do is I can increase my neurons or I can decrease my neurons. This is my learning fraction. Now this is activation. Now, as of now, do not get confused. What is all of this sigmoid RH? These are different conditions of activation. Activation is a threshold. If this neuron should activate fire or not, or fire means if this neuron should be taken into consideration or not. Think of them as few bulbs, and you have that activation, or you have that small function to decide that, okay, mujhe, if I want to build this A structure in my, in my lights, then what, some of the bulbs should not glow while some of them should glow. As simple as that, right? If I want to make certain pattern in my series of bulbs during, let's say, any festival, New Year, Diwali, or Christmas, anyone, then what do? I mean, that specific pattern of bulbs should glow while others should not glow. This is what is simple activation. Some bulbs will glow, some will not glow. Now, if I go and start it, you see, it will. This is what the learning is taking place. The same. I did show you a very simplified version of that. Now, this is just I mean, some complex patterns. You can go ahead and you can learn it yourself, right? Now, see, it is learning and learning, and at one point of time, it will learn to differentiate between orange and blue dots. Then if it is not learning, you can go ahead and change some of these problems, right? You can change some of these problems. If it is not learning perfectly, you can go and you can change. If this is something, okay, here the same blue and orange problem, what it is learning, it is learning to differentiate between these blue and orange dots. However, the next point to, now first, I hope, Mayank, is your point addressed? Is your concern addressed? Do you understand anything better from previous understanding?
Yes, yes.
Great. Great. Anyone else has any more doubt? Please ask. Okay, I guess no one is
So Anand,
speaking since the first class.
my again. So am I audible? Hello.
Yeah, 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 yeah.
Okay, so we have trained this model, okay, to differentiate between orange and blue, right?
Right.
But when we give a query to see if let's say we give green dot as an input to different categorize between which one is
Correct.
this the
Correct.
correct color, right? So how
Right.
would it react? I mean, that's what I
Okay.
want to
Okay.
understand. Right?
Sure. 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 So basically, what we talk is, this is my now. So once you have trained your model, let's say your model is trained now. The model has been trained. Your model has been trained, right? All with all of the things. I will draw this diagram again and again so that it prints into your subconscious mind and you see it even in your dreams, right? All right. Okay. So here is your model, right? This is what your model is, right? Now, this model basically we call the other part as inference. Inference. So we will write certain code around it. It will take an input and it will throw an output. Basically, we will say that, okay, orange, I mean, in our terms, it will be X comma Y, right? Because see, in 2D plane, this is simple 2D plane. In more complex, I mean, although there is no multi-dimensional, but yes, this 2D can be, we can have multiple 2D planes stacked together, which we call as multi-dimensional thing, right? I'll come to that. I don't want to confuse with advanced technologies. Like I said, it is just arrangement of information, right? So this is, if this is X and this is your Y, and this is where you have something, right? X and Y, and this is where your, and this is X1 and Y1. Now you will give this input, and this my model has this understanding that this is separator line, and it will automatically tell that if this X and Y falls into category 1 or category 2. These are the two categories it has as of now. I mean, dead simple thing. Just you pass on this to your model. Your model does that calculation that this should fall into which category, and it will return you that. Right, Mank? I mean, this uh, is it clear?
Yeah, yeah.
Right? Cool. Okay. Coming back to our perceptron point again, right? So your perceptron, all of the models that you see around is basically different arrangement of these perceptrons. In deep learning, is there any other type of AI? Yes, there is, but we will discuss it. I mean, maybe in tomorrow's session, because as of now, industry is just working on deep learning, right? All of your applications, AI agents, and everything is around deep learning, right? But is there anything else apart from this deep learning? Yes, there are a lot of things that are around apart from this deep learning, right? This perceptron is not just only, but they all revolve around same theory of updating weights. They all are revolve around same theory, right? Then you know what happened? Frank discovered this, and then what Frank did was Frank said that, yeah, I am going to build one machine bot on it, and he built one bot. What that bot used to do is that bot could actually differentiate between automatically between shapes. You show it shapes, it could differentiate shapes. You write letters on the paper, it will be able to, and it has this camera here, right? Sensor camera here. From camera, it used to read the pixel and do the calculations and do that thing. And then you know what happened? What is happening now? That happened that everyone came up with these kind of, and this is real. I mean, this photo is not real, but the scenario is very much real. You can go ahead and search the time between 1957 to 19 around 64, 65, right? There was investment raised on building the AGI. AGI term was new, but then they used to talk that we will have robots. We will have, then US came up with the theory that we will have robot soldiers, right? And this all thing continued, this everything continued. Then there were few people who used to say, no, it is not going to work. They were ignored completely. Obviously, at that time, they just had one perceptron, right? And they used to connect few perceptrons together, right? And obviously it used to solve some problems, but yes, it was far far away from the hype that was being created. And then in 19 around 64 or something, a new study was released. I mean, people were releasing studies even before. They seriously pointed out why perceptron cannot be the next. I mean, it cannot talk, walk, and see and write like people have been claiming. And then all of a sudden, people lost interest in AI. I mean, people lost that hope, and people lost that interest in AI. However, since after that, the research has been going on. It is the same perceptron on which research has been going on. Then what we did was, Google has been very active, Microsoft was active, and a lot of companies were active. Actually, the breakthrough was done by one of the researchers itself. And then they started developing those perceptrons, various architectures of those perceptrons, right? I mean, like, this kind of perceptron will be there, the behavior of the perceptron will change. This will be used for processing images. Like, it took us huge amount of time to understand that what is the best architecture for processing images. Then what will be the best architecture for processing the text, right? What will be the best architecture for processing text, and stuff like that. So do you feel any similarity between today's world and 1960s? Does anyone see any similarity? Right, guys. So this is habit of humans, and this is how humans work. Even if they, so now the whole point being that now you have an understanding that what is the limitation of current AI, and why is it the limitation? It is because of the basic architecture of the perceptron, right? Now in future, what might happen? They might actually revamp this whole perceptron. They might come up with a new thing. They might, or this whole, the basic unit of perceptron gets changed, or a lot of crazy things have started happening. you know I'll just explain few things to you, like what might happen. This is a perceptron as of now, with I1 W1 plus I2 W2 plus B equation. This might change, right? This is, as of now, this is a very simplified one. This might evolve, right? This will happen, right? Definitely, as of now, we have individual perceptrons working together. Now, what they have started doing is, they have started putting these AI models being together instead of perceptrons. Now, these AI models, they interact with each other and they come up with the solution, right? Somewhat like agents. But yeah, I mean, agents are somewhat different things. Now they have started putting these costly models, M1, M2, and M3, and then these models are interacting together and coming up with something in the future. So this is something that is happening already, right? Now, next is that, although it has been 2 hours continuously, should I continue with more half an hour, or should we continue tomorrow? Any input, team? Okay. Any more inputs? Okay, cool, 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 cool. All right, all right. Great. All right. So that means I have not bored you down. Now, whatever I have talked, right? Whatever I have talked, I just want to demonstrate this whole thing, right? And then I will be sharing this video also with you, right? The whole point being that we start practicing. This is the whole point, right? No rocket science. Now, coming to one more point, that do we need a lot of coding experience with this? See, this is the whole structure of AI. For building programs around it, yes, you will need, but just for building models, you will not need. Again, if you are building applications on top of existing models, which is happening in most of the cases, right? Then obviously the application part is there. We have to build agents. We have to build a RAG application on top of it, right? Fine tuning part is there. Obviously, fine tuning is not huge rocket science. You just need to understand these numbers properly. So what I want to say is this is more of like functional part. And even when the code is there, the code are single line codes. The codes are not complex codes. They are not complex, right? If you just keep on writing the same thing, we will be achieving it there. Right. Great. Okay. Next is right. Now you do not need to write your code on your local machine at all. You can simply go ahead and search for in your Google Colab, right? This is a complete environment, a POC environment basically. Google Colab. You just need to have your Gmail ID, and you can just Google Colab. Even in your drive, even if you are in your drive, you can access that Google Colab from here. You can go for new, more, and Google Collaborate. Right? This is the kind of environment that you will see. Very simple thing, right? Now, what I want to demonstrate is whatever I discussed so far, right? I just want to demonstrate it to everyone. If at all you guys are not following this one, we will be practicing it live. There will be a separate practical session that I will be arranging, right? So please be there in those practical sessions. The whole point is that whatever I am teaching you, I will be making you do that, right? So I don't want to mix theory and all of these things together. We will have a different practical session. And in those practical session, we will be discussing all of those things. Right. Now, I'll just go with first AI program. This is meant for data analysis and data analytics. Right. If you see now, I just go for connect here. From the first to the last, we will be doing it here. And everything is free. You do not need to purchase anything as of now. If there is anything that we need to do paid, we can take the free Google credits and we can do that. Now, once we have connected, there is some free RAM, and we get 12.7 GB of RAM and 107 GB of disk for free. Right? There is also a pro version, but yes, I mean, when you train some models for your company or something, then you can, or if you want for research, then you can. There is already some sample data that they have provided. Let's see what it is. So they have some sample data that is very commonly used. I mean, it is for beginners, California housing test. That is basically predicting the housing prices based on the data, right? So basically what it is trying to do is population, and it has median income, median values. It has 3,000 entries. So this is again California. Then MNIST data. MNIST is basically converting the digits into numbers. I mean, the same thing what I was telling you that Perceptron machine is trying to do, right? Here it is. Right? If you see, here it has a lot of 0, 0, 0. So basically, it is the pixel information that is present in these file, pixel information. Right? Anyways, we will discuss them one by one. The one more feature that it provides you is generate feature, vibe coding feature. So the point being, if AI is already coding the basic things for you, first and foremost thing, you do not need to be afraid of trying your hands out, right? Second point being, although we will generate the code, but we need to understand what is being generated so that we can debug it. As simple as that. So I hope now everyone is a coder as soon as we see this, right? Right. So you do not need to understand. You do not need to worry about it. Now I will just go, and what I will do is I'll just see these are some of the housing information. So I'll go and I'll go generate. Okay, I'll say that read California housing train CSV and generate visualization of the data. Right, and we go for generate, and it came up with, it already knows that okay, data is present here, and it came up with a visualization. Let me run it. Okay. It already generated few things. Right. Now in analysis, basically whatever problem analysis you do, this is something that we will have to learn, and I will be holding a separate session on it, breaking down the problem. This is just an introduction, because I mean this specific problem is very like, you have to find a real life problem. Come, and hence I said bring your own problem. I'll be sharing a small sheet with all of you. So please input whatever the problem you want to solve. And it can be anything. I will, at least on first, I will try to put my comments on that sheet, how we should proceed. Second, we need to understand how to analyze the problem. If we are able to analyze the problem properly, 70-80% of the solution is solved there itself. Now, first and foremost point is visualization. Visualization is the first point, that it says that distribution of, it says that this is the mean house value. That okay, in California, what is happening, that all of these houses are present in most of these ranges, 200,000. A house is costlier than 200, most of, and there are less amount of houses that are in lower range. Sorry, my bad. There are more amount of houses in lower range, and there are less amount of houses. And then there is suddenly 500,000. I mean, there might be some huge shot billionaires living in that area. Right? This is point number one. Then again, there is again distribution. There is thick distribution about around 500,000. Right? Now, this data alone might be just enough for a construction company to decide that what kind of houses in which area I have to make. I recently actually took one class on marketing AI analytics. The reason being that if a owner of a business does not understand this kind of data, you cannot ever create an edge in the market. Nowadays, it's all about analytics and finding the relation in the data. This is the whole point. The problem that many of the marketing guys are facing, that they are not able to come up with these kind of visualization and everything, all of these things. But this analysis, it can be in anything, even so. I'll be very frank and transparent. Even while starting with my classes, I did basic A/B testing of what kind of response where am I going to get more response, right? So this is the core of any business, any problem that you see, right? Now, as I said again, we will be discussing more on this. Now, this is one. This is heat map correlation of data. I have seen a lot of people with a lot of experience not being able to understand this graph properly. It is okay if you do not understand as of now. Heat map is simple correlation of the data. We will have a look at it, what it says, right? Median house value by housing median age, right? Again, this is again a kind of candle data. There are various different kinds of graph that we can see, but the whole point being that what is the different. Now, can I predict the price based on, so what all things I have? I have longitude, I have latitude, I have total number of rooms, I have total number of bedrooms, population, households, median income, and median house value. If I have this much amount of value, I can maybe predict that if what is the best kind of house this guy can buy, right? Or as of now, this is just data, right? I need to convert this data into what kind of training do I want to provide? Do I need to predict the price of the flat, or do I need to decide if this person is ideal fit for my purchase or not? So I can go for any of these things, right? As of now, what I'll do is this problem is a bit complex. I mean, as compared to what I wanted to explain. So just for simplicity, what I'll take is I'll go with the plants problem. That is, I want to decide which kind of flower this is, right? Very simple problem. Now, I just did show you the visualization part. But yes, we will come to this problem. We will solve this problem as we learn more parts. Now, in visualization part, basically understanding the iris flower dataset problem. So I have three kinds of flowers here. This is one flower, iris, and this is versicolor flower, although they may seem like similar flowers. This is one more, and this is third kind of flower. Right, this is third kind of flower. Now, based on the petals width and length of the petals, right? I want to decide that what kind of flower is this. So this iris, this is called as iris dataset. Iris dataset is very easily available, basically. So what I can just say here is that, again, I'm doing Basically, I'm generating the data. Okay. Create or load iris dataset and help me in visualizing iris dataset. Now, this is not how we are going to do with the rest of the course. I will be writing every single line of code one by one, right? And we will be explaining, because this is the whole point, but this is just a starting point. What I want is all of you just to get your hands dirty on it. So I had to start with a very simple example. So this being that, you definitely, when the time is there, we will use this generate function. There's no harm in using it when there is present, right? So what it has done is, it has already loaded, it has used a sklearn library. There's a library called as sklearn. This sklearn library is a library for usually practice of students, not very frequently used in production. In production, we use most of like PyTorch, TensorFlow. In this course, we will be mostly dealing with PyTorch. So what it has automatically done is, it has basically, and you see, uh, the Gemini is quite on to the point. And I have loaded this data. And here I have, you see, there is some error here, but yeah, I mean, we'll survive with it, no worries. It has come up with this data. Now, what it is basically saying here, so length and width of all of these three leaves is different. This one is having maximum width as compared to length. Now, this one is having length versus width difference. While here length is different, the feature that it is trying to learn is the ratio between length and breadth. So basically what it will do is, it will basically learn between length and breadth. Now, can we just create a simple program with length and breadth, and then we can just say that, okay, we are done? What is the advantage of these kind of AI problems? I mean, why use AI if it could be simply done using length and breadth? You see, the whole point of using AI is, the major advantage that it does is, you do not need to resolution the problem when in problem is extended. Now let's say I made a solution, and my solution was around, I have length and breadth ratio, right? Basically, in future, I will not, if let's say I get, apart from these three flowers, I get something else. I get, let's say, a new kind of flower, or altogether a leaf gets added, right? And it has somewhat different, I mean, so now uh, length and breadth, even if length and breadth is not very noticeable by human eye, even then we can have it. If length and breadth are not very much noticeable, that is, even the corner cases are there, even those corner cases can be easily accommodated. Now, I have created the model, I have loaded the data set, I've created a model, and then this is something in my production, that is, I have upgraded in my app, and so, right? And let's say now people come that, you know what, these three flowers are just too less, we want to add more, 5 kinds of flower. So now what I need to do is, the only process that I need to add is new data, and this new data will be prepared, and this data will be simply trained, and this new model will be pushed. That is, now comparatively complexity has reduced. That is, I do not need to go to the program again. I do not need to rewrite that existing code here, right? And I do not need to update that different rules and sets. So basically what it is doing, it is automatically learning rules. This is where AI gets interesting. So we need to know that what AI cannot do, but yes, there is a lot AI can do, right? Uh, the whole point being that we do not go towards wrong direction, but yes, we walk on the right direction. AI can dynamically learn lot of rules when taught right. Yeah, Vikram, you have doubt? Sorry, I just saw now.
Anand, no, actually, it was a long time back, but later you clarified it. Thanks.
Sure. Sorry, I'm actually looking at different screen, so hence I did not catch it up.
No problem.
Right. So automatically it learns rules. So basically, let's say if we have this solution of leaves as of now, right? We have this solution of leaves, right? We have this lens solution. Later on, when we want to add, we can simply go ahead and add it. Now, this problem is not because it is the layout problem, nothing with the data problem. I go ahead again and I say that generate, create a decision tree for create a decision tree model and train it for differentiating between these leaves, and then produce an output produce accuracy. This is a very simple problem, extremely simple problem. I'll just go. What it has done is it has created for me a decision tree classifier. Now, we did not discuss this decision tree as of now, but we'll discuss it. What it is basically a modified form of if else, right? So this is a basic classifier, a decision tree classifier. And I go and run it, and it says that accuracy is 100%. It has already, because the problem is dead simple. This is just for like demonstration. However, when we would go for this problem, that is predicting the house value, or if this customer is really a fit, like many of you come from CRM background, so finding the ideal customer fit is one of these formulas, I mean advanced form of formulas that can be utilized there. And there are companies that have been valued a lot just when they provide this formula that in, let's say, in Salesforce or any other CRM, they provide you the ideal customer fit at this kind of intelligence. Now, here we go. And next is, I want to, so here is my model, that clf.fit, and clf.predict is the function using which I basically predict the data. And I will simply now perform, I'll use some data. I have already small amount of data that I prepared. So let's say here is my, okay. Here I'm not doing anything. I'm providing with these three, and I want, instead of model, it has taken CLF. So I'll just replace the clf.predict. Okay, this, it has trained with different set of features, I guess. Okay, it has 4 features. What I can do is, okay, this is also 4. Feature name. Okay, it says it is 0. So basically what it is doing is it is predicting with 0. And then we did not actually prepare. So basically, I'll take this feature. Okay, so this is working fine. So what it has done is, so we have various categories here, right? This is category number 2. It says the first one was category number 1. And let's print out what are the total categories we have. So all the categories and category label. 0, 1, and 2, right? These are the categories it has. 0, 1, 2. Now, if you see, it is saying that this is of category number 2, right? And if I change this to the previous one, it says that it is category number 0. Now, basically, then we can map that, okay, 0, 1, 2, to which category does it belongs to. Right? So this is a very simple application of how can we just using prompts. I have not written any single prompt as of now. Now, what you can do is you can go ahead and upload lot of CSV files. You can check, you can try to visualize this data, and at least try with prompts to run this program once. Because here I have not literally written any program till now. In future, we will be writing. Now, what I want to understand, was that very tough to understand?
No, Anand, this was a good introduction.
Great. Okay, so team. So today, basically what we do is, we'll stop here and we meet again tomorrow. And tomorrow, basically from 4 to 5 is basically we will be doing the practical session. Will be again, this is one practical we have. There is another second practical that we have. We can take the housing classification or any other classification depending on how much the theory we are able to cover tomorrow. And 1 hour we will be having practical sessions. Now I will also, for practical sessions, we can even decide somewhere in between as per, I mean, so whosoever gets time in between those practical sessions, please come into the practical. We will be doing those practicals step by step. And then only we can rise to the point that we can make our own mini GPT. Building that GPT isn't a problem. Only the small perceptrons that we keep on, like this is the first unit that we have kept. Now, hope you understand how simple things can create a complex things. Right? The same thing is there. AI is not complex. It is just the proper practice that we have to put into. And that's it. Any doubts you have, kindly come up with. Any suggestions you have that you want me to improve, kindly come up with that also. Hi team, how was it?
Very good session, Anand. This was
Very informative session.
A great start, Anand. Thank you.
Yeah, great session.
Thank you so much, team. Now what we do is, I hope this time is fine, 2 to 4, right?
Yeah, it's fine for me.
Cool.
Yeah, it's perfect.
Right. Then what we'll do is tomorrow we'll cover 2 hours of theory and we will practice for 1 hour, right? Software engineers who want to convert into AI engineers, it is must that you should write the code yourself. Entrepreneurs or people with just functional skills, you can use this generative tools. So I mean, coding is not a bar. The whole point being, you don't have to be limited by any of these things. All you need to do is that just understand the things functionally. Once you have the functional understanding, you can not just consult clients. You can help in building advanced features for your organization and even for yourself. So today, what I'll do is I'll share a small sheet. I want you to come up with your own problems that we can solve. This way, we can have a big brainstorming ideation session also. So we all can put our ideas, and then we can see that, let's develop on those ideas. And I am actually very excited on solving these kind of problems. The more problems we solve, the more we brainstorm. This being the whole point. Does it make sense, team?
Yes.
Yes.
Cool. Thank you and enjoy your Saturday. I hope you all have a wonderful evening.
Thank you, Anand. You also have a
Thank you
great
so much, Anand.
Thanks, Anand, for your
Thank you, Anand.
Bye, team.
Bye-bye.